Okay, so let's talk about special right triangles. Specifically 30, 60, 90, which means 30 degrees, 60 degrees, 90 degrees. And then 45, 45, 90, which again means two angles are 45 degrees and one angle is 90. All right, before we do that, let's do a little kind of review on how to rationalize denominators. What I mean by that is I have a square root of 2 right in the denominator, and I want it to not be there anymore. That's the deal. Okay, so how do we do this? Well, anything in math, if you want to change the way something looks without actually changing the equation, we either multiply by 1, because 1 times anything is itself, right? Or we add 0. So in this case, we're going to multiply by 1. And if we're very clever about what that 1 is, so square root of 2 divided by square root of 2 is 1, right? So anything divided by itself is 1. Then this is really 6 divided by square root of 2 times 1, right? But since we were clever on how we chose this 1, it's going to help us actually rewrite this expression, right? So it looks different, but it's not actually different. Okay, so then what do? We got two denominators, so multiply the numerators together and multiply the denominators. So 6 times rad 2 is 6 rad 2, right? You have 6 of them now. And anything times itself is itself squared. So 6 rad 2 we're not going to do anything with, but square root of 2 squared, right? The square root and the square, they actually are inverses of each other, so they negate each other. So if you want to, you can think of this as square root of 2 squared, which is 4. So square root of 4 is 2. So we will get 6 rad 2 all over 2. Okay. And then notice we have a 6 divided by 2. Those will reduce. So 6 goes into, or 2 goes into 6 3 times. So that's 3 rad 2. All right. So that's how we would take an expression with a radical denominator, and by multiplying by 1, get another expression that has the exact same value. And you can try that. So take a calculator, do 6 divided by rad 2 and 3 times rad 2, and you'll get the same number. Okay. All right. Okay. So let's do 45, 45, 90 now. And so you're going to follow along on your classwork. So you're going to develop this on your classwork as I go through this slideshow. Okay, so what we're going to do is take a square. So since it is a square, all the sides are equal. So I just denoted that right with little lines through them. And then since it's a square and all the sides are equal, then I have one side is x, and all the sides are x. And again, it's a square, so all the angles are 90 degrees. All right, so that's our first part. We have a nice little square. And from that, we know a lot. We know all the sides are the same, and we know the angles are 90. Well, let's cut the square right in half. All right, so I'm going to take a line and cut it right in half and get a right triangle. Well, if I cut it in half, then I cut a 90 degree in half, so I'll get 45 degrees for this triangle. So what does this do? This tells me that I now have a 45, 45, 90 triangle with two sides that are x and x, right? So this is actually an isosceles, so these two sides are equal, and it's a right triangle. So we call this an isosceles right triangle. Well, lucky for us, we have the Pythagorean theorem. So given that both sides are x, I want to find an expression for the hypotenuse. And good old Pythagoras will do that for us. So what is the Pythagorean theorem? Square root of the hypotenuse equals sum of the sides squared. So c squared equals x squared plus x squared. I have 2x squared, so when I add them up, I'll have a 2x squared. And now let's square root both sides. Okay, so square root of 2 times x squared. Anytime you have multiplication and you're doing a square root, you can split this up as rad 2 times rad x squared. And like we talked about in the review part, this radical and the square are inverses of each other. So the square root of a square is just x. So this comes out to be rad 2 times x. And so we don't confuse it with the x being under the radical. We put the x out in front. So rad 2 times x is the same as x times rad 2. All right. Okay, well, there you go. We just figured out that hypotenuse. So if we have a 45, 45, 90 triangle, then all you have to do is give me one of these sides, and this is how they're related. So if I say, this horizontal side is 6, then this side is 6, and then this side is 6 rad 2. Right? If I say this one is 5, then this one's 5, then the hypotenuse is 5 rad 2. All right, so because I know how the sides are related, right? You give me any one side, I can figure out the rest. Okay, and that's exactly what we're going to do. So first, let's do some notes. So here's the notes, right? We're just going to write down this special triangle, the 45, 45, 90. All right, and again, this is an isosceles, also an isosceles right triangle. So if you have this triangle, the sides always have these relations, right? These two are equal, and this is rad 2 times that, right? So it's rad 2 as big as these, right? Okay. All right, so let's go. Determine the sides. So I said that if you give me an angle that's 45, 45, 90, or a triangle, and one side, I said you can get all the sides. So what I would do, and this is my process, right? Since I know that the equal sides are both x and x, and the hypotenuse is x rad 2, I'm going to fill that in. So I know this side is x. Oh, I'm sorry. So first, since it's 45, right, this has to be 45 because these two angles will add up to 90. So first I fill in my angle, and now I'll do my x's. So since these are equal, this is an x, and that's an x. And then since it's, again, a 45, 45, 90, this has to be x rad 2. Okay, and anytime you do this now, you'll always see an equation. So right down here, this tells me that x equals 5. Then this is a simple one, so if x is 5, then all I do is fill in the x's. Okay, if it were, I give you the hypotenuse, so let's say this equals 5, then I have to solve this equation for x, right? I'd have to divide both sides by rad 2. I might have to do a little bit of work, but if I follow this process where I label my sides with the x's and the x rad 2, I'll always generate an equation that will lead me into what x equals. All right? Okay, so if I do that, then there you go. So this 45, 45, 90 triangle, if one of the sides is 5, that's not the hypotenuse, right? Then the other side is 5, and the hypotenuse is 5 rad 2. All right? Okay. All right, so you want to stop this and complete class of problem number 1. Okay, so let's do the same thing. Well, same kind of logic, but now we're going to generate a 30, 60, 90, right? So one of the angles will be 30, the other will be 60, and then the right triangle. Okay, so now to do this, we start with an equilateral triangle. So just like our square, all my sides are equal. So, and for convenience, and you'll see why in a little bit, I'm going to label this side 2x instead of x. So since they're all equal, then they're all 2x. And just like on our square, all these angles are equal. And in fact, there are 3 equal angles that add to 180 degrees. They have to be 60. Okay? All right, so again, just like my square, I know a lot of stuff before I even start. Right, and just like my square, let's cut this in half. So I'm going to drop this straight down in altitude. This will be a perpendicular, okay, which means it's a bisector. So the length from this vertex to the line, or the altitude, and this altitude to the line are the same. So those are both, oops, I'm sorry, I'm backwards on my angles again. So first time did this, right? I cut this angle, well, both are true, right? I cut this angle in half, which is half of 60. So both of these angles will be 30. And then again, bisector. So both of these will be the same. So those will both be x. Okay. All right. So now what do I get? Just like I did my square before, let's pull out one of these triangles. And one of these triangles is the 30, 60, 90 triangle now. And from this work, I know that the side opposite of 30 is x, and the side opposite that we're 90 degrees, right, the hypotenuse is 2x. All right, so now, again, good old Pythagoras. We got the Pythagorean theorem, so we can find that other side. Let's label it b, and then what is it? Hypotenuse squared, so 2x squared, and then plus b squared x squared. Okay, so I'm going to put 2x, the whole thing in parentheses, because remember, it's 2x times 2x. So if I do that, 2x times 2x, 2 times 2 is 4, x squared is x squared, and there you go. All right. Okay, well, let's collect like terms. I have 4x squared on one side and an x squared on the other. Let's subtract over this x squared. So 4x squared minus an x squared. I'll be left with 3 of them. And that whole thing equals b squared. And now let's square root both sides. And I just flipped the b squared on the other side. And I flipped the equation, but it still equals the same thing. So now b is square root of 3x squared. And just like when we did the square one, now this is 3 times x squared. I'm able to split up my radicals. Rad 3 doesn't simplify, but square root of a square, remember they're inverses, so they negate each other. So I'm left with just x. And again, rad 3 times x is the exact same thing as x times rad 3. All right? And again, we put the x in front so it's not confused with whether the x is under the radical or not. That's our deal. Okay, so what do we have? Now we have another triangle. So we have a 30, 60, 90. And if that's the case, then these are the expressions for the sides. And same deal, right? If I find out x is 5, well, this is 2 times 5 is 10. Oops. And then this is 5 times rad 3 is just 5 rad 3. Okay, so you just tell me what x is, and I can tell you what the other side lengths are. All right, and that's it. So these are our 2 special triangles. right? 45, 45, 90, and 30, 60, 90. And again, make a note that the 45, 45, 90, this is actually an isosceles, so it has a nice little name, isosceles right triangle. Well, let's do another one of these. So if I could have figured out the 45, 45, 90, or the sides from that, I can definitely find the sides from a 30, 60, 90. And I do the same thing. My process is the same. So here's 30. So I'm going to figure out this angle, right? They have to add the 90 degrees. So that's got to be a 60. And now, just like I did before, I'm going to put these sides where they need to be. Opposite of 30 is x. Opposite of 60 is x rad 3. And the hypotenuse is 2x. So opposite of 30 would be x. Opposite of 60 is x rad 3. And then the hypotenuse is 2x. And again, you'll see if I do it this way, I'll always get an equation such that I can find x. And now this one is, I got to do a few steps. It's not as easy as just getting x equals like before. So let's pull it out here. I just flipped it around. So when I do the work, it'll be, I don't know, it'll look nicer. So I want to isolate x. So let's divide by rad 3. So I'll get 6 divided by rad 3. And then this is fine, right? That technically is the length of that side. But we're going to rationalize the denominator so it looks nicer. So how do we do that? Multiply by a very clever 1. And our very clever 1 is rad 3 times rad 3. And then 6 times rad 3 is 6 rad 3. And then just like before, right? Rad 3 times rad 3 is rad 3 squared. So the radicals and the square will negate each other. So I'm left with 3. And then 3 goes into 6 2 times. So 2 rad 3. Okay, so now I know what x is. So I can plug in x to both of these. So if this side is 6, then this side has to be 2 rad 3. And this side has to be 2 times 2 rad 3, which is 4 rad 3. So if this is a 30, 60, 90, and the horizontal side is 6, these have to be the lengths of the other two sides. Okay. Okay. That's it, actually, the end of the video. So stop this and do the classwork problem number 2. And there is a process at the end of the classwork. So after you finish classwork or the problems 1 and 2, think about your process and write it down, right? How do you approach these problems?